Sine alpha plus beta is equal to sine of alpha times cosine beta plus cosine alpha sine beta. Now the subtraction, alpha minus beta, be the same deal, just change the middle to minus. My alphas look like Jesus fish, so I'm sorry about that. Okay. This is a side note. There's also these identities. Cosine of pi over 2 minus theta is equal to sine. And sine of pi over 2 minus theta is equal to cosine. Okay. They find the tangent. Then we get to work. So this is these are the important ones right here. This is kind of like a little side note. Tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta over 1 minus tangent alpha tangent beta. All right, the subtraction will be the same, just swap these signs here. Excuse me. Okay, so this is all we need for this section. You can get to the examples. Okay. So the question will start, the homework will start like this. Find the exact value of cosine 75 degrees. So you gotta notice is like, well, there's two angles that can split this into that exist on the circle, right? Which two angles can I break 75 into that are on the circle? Let's think about this, right? So 30 plus 45 is 75, correct? So you want to choose angles that are on here to split the angle. So cosine of 75, and I'll switch back in a moment, is equal to cosine of 30 plus 45 degrees. You see what I mean? So now these exist on the circle, so I can use the first equation up there. I'm going to number them so I can refer to them. This is 1, 2, 3, 4, 5, and 6. So using equation 1, can easily split this up, right? So the formula says that this will be, so this is going to be my alpha and beta. It does not matter which one is first. You can put 45 first if you want. Who cares? So the formula says cosine of alpha times cosine of beta minus sine of alpha times sine of beta. You see how this works? It's not too bad, right? Okay. One moment. Okay. So let's use our unit circle, right? So cosine of 30, oops, apparently didn't let her enter. Cosine of 30 is going to be what?
Square root of 3 over 2.
Yeah, square root of 3 over 2. Cosine of 45, I'll do the hard one for you, right? Sine of 30, what's that one going to be?
A half.
1/2. Sine of 45. Here we go. So then you just multiply and add it up and you're done. So square root 3 times square root 2 is a square root 6. Because you can multiply roots. You cannot add them though. All right. Minus 1/2 times square root 2 over 2. So that's square root 2 over 4. Now they're the same denominator, so I could combine them into this, but this is all I can do. Since they are not the same root, that's it. Is there any questions about number 1? Does that make sense?
I think so.
All right, let's do another one. The next one is going to be in radians, so if it feels harder because they're fractions, but if you don't like it,
Could
you
you
can
go
always
back
convert it.
just 1 second? I just need to see that real quick.
Yeah, no big deal.
Okay, I'm good. Thank you. Sorry about that.
No, everyone good on first page? Okay.
Jack. Hello. I'm
Yes.
sorry. 3, 4, 5, 6. Okay, can you just do? You said you added them. Can you explain that again real quick on the second to the last line?
Sure. So right here, from here to here.
Yes.
So see how they're the same denominator?
Square root of 6 over 4.
Yeah, square root of 6 over 4, square root of 2 over 4. So since they're the same, you can subtract them, but they don't actually combine. You see what I mean? Like for example, if you had
Oh, you multiplied them, right? I got it. Right on the top, that's how you the 3 times 2.
Yeah, square root 3 times square root 2 is square root 6.
Okay, got it.
Yeah, when you have square roots, if they're both the same root and they're multiplied, you can do that. But they have to be the same. Like if this was a cube root and a square root, you cannot do this.
Okay. I got it.
feel like this section seems a lot easier compared to the last one, right?
Yes.
Yeah. So most of the sections in chapter 8 are just using formulas, but they will randomly make you prove stuff using those formulas. So that's where it gets harder. Formula. Okay. Find the exact value of cosine pi over 12. So see how this one's not as obvious, right? How would we break that down into two angles on the circle? Because it's a fraction. Unless you're very comfortable with fractions and you're like, oh yeah, that's simply pi force minus pi 6, no big deal. But I'm sure most of us are not that comfortable. So what we could do is change it to degrees and not worry about it, right? Because technically we can convert it anytime we want, right? So cancel that out. 180 divided by 12.
15.
Yeah, see, that would be 90 over 6. What'd you get? Sorry.
15.
15? Oh, okay.
Uh-huh.
Cool. Okay. So 15 is a little small, right? And it's not on the circle. So we have to use the difference because of that. So what we can do, basically, so you know what? I don't want to deal with this radian stuff. I'm going to use 15 degrees. So I could use cosine of, let's see here, 45 degrees minus 30 degrees, right? See what I mean?
Oh, that's much easier.
Yeah, because if you would leave it this way, you'd have to say, oh yeah, I know what fractions those are. Those are clearly pi force minus pi 6. That may not be clear. So yeah, I would recommend degrees if you don't want to deal with it. I won't judge you. So use our formula here. The difference is number 2, I think. It's going to be cosine, cosine, sine, sine, with a plus in the middle. Okay. So alpha and beta. So this will become cosine of beta minus sine of alpha sine of beta. So now we just look it up. This is square root 2 over 2. Cosine 30, that'll be what? Square root 3 over 2, is that right?
Wait, I have a really quick question.
Yeah.
Would that be a plus in the middle?
Let's check. Let's double check. I think you're right. If it's minus, it should be plus. Yeah. Yeah, with the cosine, it's opposite. Sine is the same.
Cool.
Thanks. I like when you point out errors right when it happens, not 10 steps later. Makes me happy. Sine 30. What's that going to be? Right, so sine 30 is 1/2. Cosine 30. Yeah, it's all good. So just multiply it out and we're done. square root 2 times square root 3. Looks like it's going to be very similar to the last one. Plus square root 2 over 4, which is really square root 6 plus square root 2 over 4. Nothing else we can do. So yeah, the first, like, I don't know, maybe first 30, 40% of the homework will be stuff like this. And then eventually they're going to be like, you know what? Prove stuff using those identities. So let's move on to the harder stuff. You guys have any questions on one or number one or number two?
They're all right. They're not too hard.
Okay. All right, cosine. Oh, let me put the instructions. Instructions are establish the identity. All right. Cosine alpha minus beta over sine alpha sine beta is equal to cotangent, not cosine. Cotangent of alpha cotangent of beta plus 1. Okay. So we need to prove that this is equal, that it's true. So we need to pick a side and then start work your way to the other side. This one looks slightly more complicated, plus I see a difference. So that means I could apply the difference formula, right? Over here, I'm like, I guess I could try fractions or something, but this makes me want to choose the left side.
Could you bring up the paper bit?
All right, so the difference formula, I already forgot what it was. Let's look at it. So we just used, right? Alpha minus beta. Okay, so the top will be cosine alpha cosine beta plus sine alpha sine beta over sine alpha sine beta. Okay, so that's what I'm working with. Oh, that doesn't look too bad. I think I see the path. So I see a fraction on top, right? Well, this is one big fraction, but I see that I could separate this into two fractions, right? This over this plus this over that. Because that's what fractions do, right? So I could separate it this way. Do you guys agree with this?
doesn't that equal 1?
Yeah, it will be. It will, because that's what we want to see, right? Because we have a 1 over here.
Right.
So that's a good sign. Okay, so right here, though, do you see how we can create the cotangents? Now you see how these pieces are cotangent?
Yeah.
So this becomes cotan alpha, cotan beta plus 1. So this is algebra. This is going to be just what's called the, I think we called it ratio. Well, quotient. That's the word we used last time. Quotient property. And that's what we wanted to show, right? We got to the right-hand side. So any questions on this problem?
How does it become cotangent? I'm not getting that part because I don't see that in the formulas.
Well, what is cotangent?
Oh, so we're going.
Right, it's cosine over sine is cotan.
Oh,
Cosine
okay.
over sine is cotan.
So that's back from our previous notes, right?
Yeah, I think it's from like chapter 7.
Okay. All right. That makes sense. Okay. Thank
Mhm.
you.
Like that's when we had a list. It said like tangent is sine over cosine. Secant was like 1 over cosine, right? You remember?
Yes,
Yes.
I found it.
Oh, okay. Okay. Let's do solving equation type. You guys okay on example 3?
Yes.
Oops, 4. Solving a trig equation. Okay. We've been solving some trig equations already, but this one will be a little bit different. Sine theta plus cosine theta equals 1, where theta is between 0 and 2 pi. Okay. So there's a few ways you could try this out. Let's see here. So the techniques that we've been using, usually we try to factor if we can. We try to create fractions if possible. If you see quotient properties, you can also try conjugates and see if that works. But we can also square both sides. So these are all possibilities. I think conjugate or squaring would work. Let's try squaring. I square both sides. This one's easy, right? It's going to be a 1 on the right hand side. This guy here would be this, right? Remember how we said we got to distribute? So sine times this, sine times that, cosine times this, cosine times this. Or you can use a formula, which will give you sine squared theta plus 2 sine cosine plus cosine squared theta. And we know sine squared plus cosine squared is going to be 1, right? So I'm going to rewrite it just to show that. So this right here is 1 by the Pythagorean identity. Excuse me. So this is 1 plus 2 sine theta cosine theta equal to 1. Now if I subtract the 1 over by subtraction, I get 2 sine theta cosine theta equal to 0, right? Okay, and now that we have it set to 0, we have a property that says I can, well, first of all, just divide both sides by 2. So if I have something times something equal to 0, then I can set each one equal to 0 anytime. So when is sine theta equal to 0? Between this interval. Right, theta will be equal to,
0.
0 and pi.
yeah, 0 and pi. When is cosine equal to 0?
Pi over
Pi over
2.
2 and 3 pi over 2.
So just list them in here and we're good.
But how do you know that?
How? Like, let me show you. So we gotta look at our circle. Sine is 0 at 0 because the y is 0. The y is also 0 at pi. So that's where the first two came from. And then they said, when is cosine equal to 0? In other words, when is the x value 0? Well, that happens at these two spots. So pi over 2, 3 pi over 2.
So is there note somewhere that tells us that sine is 0, cosine is 0?
What do you mean?
No, yeah, like how do we know that sine is there on the chart just because it equals 0?
So you're wondering from, okay, well, let's talk about two things here. So from here to here, we use the 0 factor property. Do you remember from algebra when we had something like this? you would set each one equal to 0, right?
Sure.
So it was the same deal here. So you would say, oh, x plus 2 is 0, x minus 3 is 0. So we did sine theta is 0, cosine is 0. So then the question becomes, what angle makes the y value 0? What angle makes the x value 0?
Oh,
we
so
have-
we know that sine is x and cosine is y.
Yeah, well,
Or-
yeah, this one's x and this one's y.
Oh,
That
well,
will
yeah.
always be true.
Okay. Thank
That's
you.
yeah, no problem. That's how it's defined. So don't forget. You guys have any more questions? Number 4. Okay. All right. Okay, so let's go to 8.6. And let me give you some formulas. After the formulas, I'll let you take a little short break. So double angle and half angle. Formulas. So we're gonna need all of these guys for the identities, the proofs, but also to solve equations. So here's the double. Have I sent you guys a sheet of all the formulas? I can't remember.
I don't think so.
Okay, I'm gonna find another one if I didn't. So
I
you
think
can
you
have.
sent us a link.
Okay. Yeah, I'll send a PDF then. All right, so sine 2 theta is equal to 2 sine cosine. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Cosine 2 theta is equal to 1 minus 2 sine squared theta. Cosine 2 theta is equal to 2. So, by the way, the double angle for cosine has 3 forms. All right, cosine squared theta minus 1. And then the one for tangent is equal to 2 tan over 1 minus 10 squared theta. All right, so here's all the double angles. Give you some more here. These are useful power reducing formulas. These are very useful in calculus 2. Might not come up a lot in this section, or in this class, but will come up a little bit. Sine squared is equal to 1 minus cosine theta. Actually, 2 theta. Over 2. Cosine squared theta is equal to 1 plus cosine 2 theta over 2. Tangent squared theta is going to be equal to this quotient, actually, which would end up being 1 minus cosine 2 theta over 1 plus cosine 2 theta. Man, the sun's setting right through my window. Okay. Half angle formulas. All right. So sine squared of alpha over 2 is equal to 1 minus cosine of alpha over 2. Sine, actually, cosine squared of alpha over 2 is equal to 1 plus cosine alpha over 2. Tangent squared of alpha over 2 is equal to 1 minus cosine alpha over 1 plus cosine alpha. Man, that light's messing me up.
Professor, Professor.
Can you hear me?
Oh, there you are.
Oh, shoot. Was I on mute this whole time?
I think so.
Oh, man. I don't know when that happened. Oh, it must be when I moved my... Okay, sorry. Thank you. All right. Cosine alpha over 2. All right, so the way you find these, or the way they were derived, they square root both sides. You see that? That's where these came from. Number 4 and 5 and 6 will be square root. But notice how they have a plus or minus. Those will be determined by where alpha is. And we'll talk about that in a little bit. So you need to decide, like, all right, is it plus or is it minus? Tangent of alpha over 2 is going to be plus or minus the square root (1 minus cosine alpha over 1 plus cosine alpha). And then there's tangent is another form, one last one here. This will be equal to 1 minus cosine alpha over sine alpha, or you could use sine alpha over 1 plus cosine. Okay, so those are all the formulas. Let's take a short break. 7:03. Let's come back at what, 7:15. So if sine theta is equal to 7/8 and theta is between 0 and pi over 2, find the following. All right. Find sine theta, sine of 2 theta. So since the sine of 2 theta on the formulas doesn't have anything, you don't have to worry about the signs or whatever. You don't have to choose plus or minus, etc. We're going to just use the formula. So we know that sine 2 theta, based on the first formula for the double angles, is going to be 2 sine theta cosine theta. That's an ugly triangle. So they said that sine is 7/8, right? Doing Pythagorean theorem, you'll find, I'm going to skip that step, that this is square root of 15. So sine is 2, so 2 times sine, which is 7/8, times cosine, which is square root 15 over 8. So that will be 14 root 15 over 16, which is 7 root 15 over 8. Oops, actually, that's not true. 8 times 8 is 64, isn't it? Reduce that would give us 32. There we go.
So the 2, we wouldn't multiply it by the 8s at all.
No, because it's technically 2 over 1 because it's a whole number.
Oh, okay. So it's just going across.
Mhm.
Okay.
But that's all for that one. Is there any questions on part A? So we just use the identity and then the triangle to help us out. Okay, so this is the same information for part B. So we can still use this triangle to help us out here. Oops, I skipped a. So find cosine of 2 theta, which means we need to use the double angle. And there's 3 different ones. I'm going to use the one with sine because that's what they gave us. So might as well use the sine one. So this will be 1 minus 2 times sine squared. Sine being 7/8. So it'll be 7/8 squared. That'll be 2 times 49 over 64. Does that make sense what we're doing? Because sine was given as 7/8, right? No, 1 second. So let's simplify this. That'll be, so we can multiply it straight across, or we can reduce this, right? This is over 1 technically. So 1 minus 2 times that, so reduce the bottom, that'll give us 49 over 32. Changes into the same denominator. That would give us 32 over 32. If you multiply top and bottom of that 1, and then subtract. So that would be 32 minus 49. What is that? Negative 17, right? No.
I have a quick question as far as how we got to 49 over 32.
Yeah, sure. So we have 2 times at 49 over 64, right?
Mhm.
So that's the same as saying 2 times 49 over 64. So you could reduce it by saying, oops, forgot my bottom part here. You could reduce it by breaking down the 64 into 2 times 32. So that's technically what happens when you reduce, right? You divide the top and bottom.
Got it. Cool. Thanks.
So those 2's are gone. Okay. Let's do part C. Oh man. I need to get a new notebook. Sine theta over 2. So the formula says it's equal to plus or minus the square root of 1 minus cosine theta over 2. And they also gave us information that theta was between 0 and pi over 2, right? That's what they said. Yeah. This is the one number 1. This is part C. But notice they have a theta over 2 in here, not a theta. So if you divide everything by 2, you would get this, right? So this will tell us whether or not we should pick plus or minus here. Because we're using the formulas, but they don't tell us which one to use. That's determined by the angle. All right. So let's look at the circle, unit circle. So 0 to pi over 2 is quadrant 1, right? So if I divide by 2, it becomes 0 to pi over 4. That's what we showed just now. So that would be still up, it'd be from here to here, right? So I'd cut the interval in half. But what matters is x and y are both positive here, right? In quadrant 1, and when we divide by 2, we're still in the same quadrant, so the sign doesn't change. So because of that, we're going to choose the plus, not the minus. Okay, so we're going to use positive, so we don't have to write the plus anymore. 1 minus cosine theta over 2. Cosine we found to be, what was it? Square root 15 over 8, right? Yeah. So just plug that in here. So 1 minus square root 15 over 8 divided by 2. So I need to subtract these fractions and reduce this, and then we're done. So we can do that over here somewhere if it makes more sense. But that's what's inside the radical, right? So get the common denominator, this would be 8 over 8 minus root 15 over 8 divided by 2, which is the same as 8 over root 15 over 8 divided by 2. Which would give us 8 minus root 15 over 16, right? Because it would technically be, you would flip the fraction, right, when you divide. It'd be times 1 over 2. So in here, you get 8 minus root 15 over 16, which would, you'd square root the bottom here, which would give you square root of 8 minus square root 15 over 4 outside the root. So this would have to be done inside, but I think it looks better separate, just so you can see what's happening. Okay, you guys cool on part C? Do you see how we chose the positive and how those fractions worked out?
Yeah, I see that, but I do have another question about how do we get to 8 minus 15, like the square root of 8 minus 15 over 4?
From here to here,
Yeah.
you square root 16 and you get 4.
Oh, and it's not in the, yep, okay.
Yeah, it's outside now at this point.
And how did we get the 8/8 minus square root 15/8 over 2?
This step here.
Mm-hmm.
Oh, so we gotta get the common denominator, right? So you have to multiply 1 by 8/8. So you change this 1 into this. And then once you've done that, you can combine these fractions into 1. Then you divide it to get the 16. Does have any other questions on this? All right, let's do another one that's similar. Given that cosine theta is equal to negative square root 5/7, and theta is between pi/2, theta, and pi. Find the following. So find part A, sine 2 theta. So it helps to start with the triangle, make sure we build it. Here's theta. So which quadrant is this? Pi/2 to pi.
Two.
Yeah, it's quadrant 2, and in quadrant 2, cosine is negative, right? And sine is positive. So this would be the hypotenuse, and I'd have to put the adjacent side as negative root 5 because of the quadrant. When you do Pythagorean theorem, the y must be positive, which would be 44.
And 44 came from,
The Pythagorean theorem. So you'd have to solve for it.
gotcha.
So once you have those, you can define sine, right? Over 7, which is technically, 2 root 11/7. Yeah, because you can reduce the root 44. Cosine. It's going to be, oh, they gave us cosine, so we're good.
I'm going to be completely honest, man. I don't know how to reduce square roots like that. How-
Yeah, sure.
Okay.
This is a word. What's going on? Square root 44 is the same as saying square root 4 times 11. So you separate them. So square root of 4 is 2. 11 just stays there.
Well, that's fantastic. Thank you.
Okay. So now we have sine, cosine. We should be able to answer the question for sine 2 theta. So sine 2 theta is equal to 2 sine theta cosine theta. So sine we found to be 2 root 11 over 7 times cosine, which was given as negative root 5 over 7. So that will be a negative 4 root 55 over 49 when you multiply it all out. Right, so root 11 times root 5 is 55. 2 times 2 is 4. 7 times 7 is 49. Any questions on part A?
Can you go back up real quick? I was still writing the little notes on the top part. There you go. Okay, got it.
Okay. Okay. Let's do the half angle so you can practice that. Let's skip to part C. Sine of theta over 2.
I have a really quick question just about like the
Mhm.
like what it all means. Does that mean like that's twice the size of the angle in that triangle?
Yeah, technically this would be, 2 theta. So yeah, it'd be double. Right.
Okay. Cool.
So basically what we're doing is finding the double angle using the definitions of the original angle.
I forgot it was called double angle. Thanks, man. I appreciate it.
No, it's okay. Don't worry about it. All right. So we got to choose, right? Plus or minus for the half angle. 1 minus cosine theta over 2. All right. So we said that the theta was in quadrant 2, right? So where is the half angle? Where is theta over 2? So you'd have to divide everything by 2 to see it. So it'd be theta over 4.
You know, I'm sorry, but I'm not seeing, how are you seeing that theta? No, pi over 2 is in quadrant 2, right?
No,
Is that what you said?
I said theta is in quadrant
Yeah,
2.
quadrant 2.
So this right here means theta is between theta pi over 2 and pi. So where is that? So we look at the circle. So pi over 2 to pi is where theta is. So quadrant 2, right? And then when you divide it by 2, you get theta over 2. So where is the half angle? We get pi over 4 to pi over 2. So now we're in quadrant 1.
Okay.
So that would tell us to use positive. So we use plus right here, not the minus. If it would have stayed in quadrant 2, sine is, well, actually sine is positive, it would have mattered. But if we had cosine, then we would have picked minus if it stayed in quadrant 2.
I guess I'm looking for theta and I don't see it, but in quadrant 2. But I guess that's what's confusing me.
Yeah, so theta means just some angle. The angle is somewhere between here.
Okay.
And then half the angle is somewhere between here.
Yeah, I get that part. Okay.
Does that make sense, or is this, you still
Yeah,
confused?
yeah, just the theta part is kind of throwing me off a little bit, but it's always going to be there, right?
Yeah, theta just ranges. I mean, we can write it the other way if you want. We could say pi over 2 to pi is quadrant 2, right? Then if we cut it in half, that would be theta. I mean, pi over 4 to pi over 2, which is quad 1. Same thing, right?
Yes.
With theta, he's saying that it's in between pi over 2 and pi.
Right.
Okay.
Theta's not, it's just
A
know.
variable, right?
Mhm.
it's just it's an angle in between pi over 2 and pi.
Right.
Okay. Thank you.
Yeah. So put it all together. It's a variable that ranges between those two values. It could
Okay.
be anywhere in there. All right. Let's see. So let's plug it all in and we're good. So cosine we said earlier was negative square root 5 over 7. So we're going to pick 1 plus, actually minus. One minus a negative square root 5 over 7 divided by 2. So then subtract these. So you're going to get the common denominator of 7 over 7. So that would give us 7 over 7 minus minus is a plus square root 5 over 7 divided by 2. This time I'm going to do it inside the radical. So that'll be 7 plus root 5 over 7 divided by 2, which finally gives us 7 plus root 5 over 14. Do you guys see the fraction steps? No, we're adding we're adding 1 plus this here, just like we did earlier. The same thing. Okay. Think. All right, we'll have one last example, I think. Let's see here. No, I don't think we have time for that one. Dang it. Let's do a short one. So sine of 67.5. So we got to pick an angle. So if we double this and then cut it in half, does it appear on the circle? So we can force a half angle formula. So what is 2 times 67.5?
135.
Is 135 on the circle?
Yes.
Yeah, so since it's on there, we will rewrite the question as 135 over 2. Here it is, yeah. So we get 135 over 2 and then apply a formula. So this is my theta, right? So the formula says that this will be equal to plus or minus the square root of 1 minus cosine theta over 2, right? That's from the formula.
Okay.
But theta is 135, so you just plug that guy in. But do I put plus or minus? Which one?
Minus.
Let's see.
Wait.
Yeah, so 135 is in which quadrant?
2.
2.
And sine, is it negative or positive there?
Oh, positive.
Yeah, so we'll pick plus again.
Okay.
So we're good. So go ahead and plug it in. So 1 minus cosine of 135 over 2. Cosine of 135 is negative square root 2 over 2, correct? Let me switch back over. It's right there. So this will be 1 minus square root 2 over 2 over 2. So subtract the fraction, divide by 2, just like we did the last two examples, and we're done. So introduce the common denominator for the top part. It's 2 over 2 minus root 2 over 2 divided by 2. It's a lot of 2's. So then we get 2 minus root 2 over 2 divided by 2. This looks really weird, but that's how it is. If you cut half in half, you get a quarter, right? So 4. Square root of 4 is 2. And that's it. It's positive. There's just a smudge there. So we have time for. So what I suggest is have all your formulas on one page, and I'm going to try to find one for you as well. Also, get comfortable with the formulas. So when you're asked to prove things, or when you see when they're useful, they won't be too difficult. Okay. Guys, have any questions on 8.6?
I have a question, but not on 8.6.
What's your question?
It's regarding the calculator.
Okay.
Is the TI-84 good for like Cal 2 and stuff?
Yeah, that should get you. Yeah, that should be fine.
What about anything higher?
Usually 84 and 89 are good for Cal 1, Cal 2, Cal 3, but sometimes, what's your major?
Electrical engineering.
Some engineering professors might give you crap about 89, but most will be cool with 84. Once in a while, you'll have a guy who says no graphing at all. If that happens, I would get the TI. Actually, what was it? This is the one I recommend. The best non-graphing is this guy. Shoot, where is it? One second. You know what? It's on the syllabus, I think. Just give me a second. I forgot the name.
Oh.
Oh yeah, it's TI-36 Pro.
Oh,
That,
okay.
that one's the best non-graphing because it can do a lot without graphing, and it has parentheses. It can do fractions for you. It does vectors, dot products, a little bit of matrices, and a little bit of data. Not too much.
Yeah, for the matrices, it's kind of limited, but that's the one that I have.
Yeah, that one's really good. But yeah, matrices you're limited at like 3 dimensions.
Right. Yeah.
The 34 can handle n dimensions, but you'll for the most part that one should be allowed, but it's not allowed on state exams, and some instructors, like I said, might give you crap, but it's pretty rare.
Okay. Thank you.
Mhm.